Okay. Hi, I'm Nick Nielsen, and this is Big History for ETI. So, sometime in the late 18th century, the Scottish poet Robert Burns went to church, and he was sitting there, and the woman he was looking forward, and the woman in the pew ahead of him had a louse
I have.
crawling
Do you hear
on,
me? I
and
I have not sound from conference.
and so he wrote a poem, a very famous poem called To a Louse. And it includes the famous line, "Oh, wad some power the gifty gie us to see ourselves as others see us." And that's, one of the big challenges in big history is how do we see ourselves as others see us? And this can be interpreted as an approach to the attempt to achieve objectivity in history. So historians have often discussed the problem of objectivity in
Do you
history.
hear me?
Yes, we hear you. Uh,
I have
Historians
no
do not
answer,
themselves agree
unfortunately.
on what objectivity is. But here's one version from a 20th century historian. So this is a quote from E.H. Carr, Ted Carr. The
I
historian
have
has a capacity to
some
rise above
questions
the limited
in the
vision of
chat.
his own
What
situation in
about the
society and
resource of the
history.
planet
And
itself
the
being
historian has
very
the capacity to
conductive
project
to
his vision
life?
into the future in such a
Sure,
way
they
as to
could
give him
find.
a more profound and more lasting insight into the past that can be attained by those historians whose outlook is entirely bounded by their own immediate situation. So, how do we rise above our limited vision? Well, one way is to conduct the thought experiment of asking ourselves, uh, would we have an objective history of humanity if a history of humanity were written by some ETI? So we were observed from outside by somebody from another intelligence, and they wrote our history instead of us writing it and us putting our biases into it. Would that be an objective history? Um, so we can turn that around and say, if we are writing history of the universe, would that be an objective account of the universe from the perspective of some extraterrestrial intelligence? Are we writing a history that would be an objective history for an ETI? So scientific history, of which big history is an instance, can appeal to scientific standards of objectivity of knowledge and obtain objectivity and rigor through that. But is our science commensurable with the science of other times or the sciences of other places? How would our big history compare to a big history written by a big history written by ETI? How would that compare to a big history written by us? Would human science and ETI science be essentially the same or not? One way to answer the question of how we rise above our limited vision is what Carl Sagan called deprovincialization, although he also used the term deparochialization, basically interchangeably. So a 1980 quote from Cosmos is the study of a single instance of extraterrestrial life, no matter how humble, will deprovincialize biology. For the first time, the biologist will know what other kinds of life are possible. And 6 years before that, he had written in a paper, biology suffers from a deadening provincialism, an inevitable parochialism, like the physics of
Do you hear
falling
me?
bodies before Newton showed the same laws applied to the motion of apples in England, the moon and circumterrestrial space, and planets around the sun. So we can extrapolate the Carl Sagan's idea of
Do you hear me?
deprovincialization or deparochialization
Somebody?
by
Anybody?
um, saying that this can be applied to any uh, this can be applied to any uh, science whatsoever. So we can say that there's a deprovincialization principle according to which uh, uh, we can deprovincialize any science. So there is implicit in every terrestrial or originating science the telos or the end of deprovincialization. And the sciences that we originate and develop on Earth will ultimately be generalized for the universe
Thank
entire.
you. Thank you for your
Deprovincializing
attention.
and de-anthropomorphizing science means formulating a non-parochial scientific methodology with non-parochial observations, non-parochial measurements, non-parochial experimentation, non-parochial uh, concept formation and scientific research programs. So how exactly do we act upon the imperative implied by the deprovincialization principle? One instructive comparison is the comparison between exobiology and astrobiology. The terms aren't clearly defined and they've changed over time. So, you know, with that in mind, in 1962, we have a definition of exobiology as a broad definition of exobiology could be the detection, study of extraterrestrial life and its impact on the origin of evolution on life on Earth and elsewhere. So it's specifically about life off of Earth. A 1996 definition of astrobiology from NASA says the study of the living universe. And so if we compare exobiology and astrobiology, when exobiology was first proposed, some people ridiculed it as a science without an object because we don't have any extraterrestrial life. But astrobiology doesn't require extraterrestrial life because astrobiology places terrestrial life in a cosmological context. So astrobiology remains a science regardless of whether or not life on Earth is the only life in the universe. Astrobiology could ultimately be a context in which exobiology can be integrated if and when we find life elsewhere in the universe. And in that sense, astrobiology can be a model to the other sciences. So at present, exoplanetology is a science today because we can actually have the science now to partially observe to a limited extent other planets, peer planets to our planets in our solar system. Exobiology can't be a proper science in this respect, yes, because we do not as yet have any peer life to study. Exobiology will become a science if and when we find peer life derived from distinct origins of life events. Astrobiology, however, can expand its conceptual framework, becoming the context in which we eventually can construct exobiology. So what do I mean by peer emergent complexity? So I'm going to say that these are lineages derived from common boundary conditions. So in more detail, two or more forms of emergent complexity derived from the same or largely similar boundary conditions. So this is a twofold generalization of the idea of a common ancestor in evolutionary biology. It's a generalization across multiple thresholds of complexity, not just biology, and a generalization from noting a specific ancestor to noting the conditions into which that allow for that ancestor to come into being.
Your slides are not advancing. If you could go back to PowerPoint and just kind of present from there, that's what everyone is seeing.
Ah.
Can you go escape and then just go from here?
None of this makes any sense though if they're not animated.
Okay.
Because the images are superimposed over each other.
Yes. I don't know how to do that because we're just seeing the first screen.
You're only seeing the first screen.
Yeah, sorry.
Oh, okay. Well, I thought I was advancing all this time. Sorry. Okay, my slides are set up so they have to be animated, but apparently nobody is seeing the subsequent screens, so this might not make much sense without the animation. But you can see here. I don't know if you see the current screen or not, but we have the thresholds of emergent complexity familiar from David Christian's 8 thresholds of emergent complexity, and up on the left we've got those that are visible on a cosmological scale. On the right, we've got provincial emergent complexities that are only visible on Earth. And where the red line goes down through and divides the two, you have the threshold of which we would find peer emergent complexities. So even within our peer emergent complexities on Earth, like life, collective learning, agriculture, and the modern revolution, we have multiple emergence. So life on Earth, we have an incredible biodiversity. We have, archaea, bacteria, and eukaryotes, and a collective learning scale. We have an enormous linguistic diversity, many different scripts, many different conceptual frameworks associated with different languages. At the level of agriculture, we have different systems of agriculture based on the staple crops that are available in different geographical regions. And since modernity, we have seen science and political change and industrialization roll out differently in different parts of the world. So even confined to provincial emergent complexity, there are distinct forms of complexity that branch out at each threshold of emergence. So deprovincialized science would be when we were able to combine our observations of provincial emergent complexity on Earth with peer emergent complexities elsewhere in the universe. And so here on this slide, I had a number of big history emergent periodizations that you can't see here because I can't sequence through the animations. But this is the Drake equation, of course, and that's essentially big history in spirit, even if it's not big history in properly speaking or narrowly speaking, because each term in the equation represents a different level of complexity effectively. And we have many different versions, like one of the other images on this slide was Robert Hazen's different periodizations of Earth. So Robert Hazen doesn't explicitly use the language of big history, but he does segment the geological time into different periods of Earth that are the blue Earth when all the oceans form, and gray Earth when granite forms, and that sort of thing. So emergent complexity periodization, it's important to note, is an ordinal quantification, but not an interval quantification. So what that means is that the order matters, but the interval is variable. So yesterday, Lowell had a slide of the coelacanth, and there's behind this picture, there's a picture of the coelacanth to indicate stasis. And in some clades, we have, extremely slow evolution. So there are fossils of the coelacanths that are 400 million years old, but phenotypically, it's identical to the coelacanth today. So, but on the other hand, you get the fish on the right is from the cichlid family, which is well known in Lake Tanganyika in Africa for having speciating on average every 200 years. So it would be entirely possible for you to dine on a plate of tilapia, which is also known as St. Peter's fish, that is a species that did not exist when your great-grandfather was a boy. So how do we recognize non-parochial complexity? So we've seen after macroevolutionary bifurcation, emergent complexities can follow separate paths. Yesterday, Claudio Macconi mentioned the molecular clock, which is always ticking away inside the genome from accumulated mutations, but it doesn't necessarily push a clade into a different rate of evolution, or it doesn't necessarily pass on to another threshold of emergent complexity. So once you get a split, they can go by very different paths that evolve at different rates. So you still have this master framework of emergent complexity that can integrate both parochial and non-parochial complexity, but we have to revise this framework as we discover novel forms of emergent complexity, because distinct forms of complexities will have their own origin stories and their own destiny. So, for example, at the present time in physics, we have the problem, in physics and cosmology, we have the problem of dark matter and dark energy. Since we can't say what those things are, we don't know what their origins are. But when we're able to figure out them, or we have another physics paradigm in which we can interpret our observations in a way that makes sense, is consistent with all previous observations, then we might have to rearrange our emergent complexity sequences to account for things in the past that we didn't know about, and for developments in the future that we don't yet know about. So these different emergent complexities, including peer complexities and non-parochial complexities, they might cross paths with our history, but they might have their own histories, and they might have different origins and different destinies. So anything that proves to be impossible to categorize within our present conceptual framework is a convenient red flag to tell us we might be dealing with a non-parochial complexity. And we actually face this problem all the time with origins of life science, as Grinnan was just saying in a previous talk about viruses, that it's not clear whether viruses are alive or whether they're life or they're not life. So when you have this, what logicians call the law of the excluded middle, or tertium non datur, which is either it is F or it's not F, sometimes that classification fails. And when that classification fails, it's an indicator to you that you need to supplement your conceptual framework with additional concepts that we're not familiar now. So we have to introduce novel concepts to account for our novel observations. And astrobiology is an example of how we do this, because we're expanding our conceptual framework of a discipline that studies terrestrial emergent complexity, but it might someday be supplemented by the non-parochial complexities if we glimpse biosignatures in the atmospheres of other planets. We'll have a framework in which to put that, and perhaps develop an exobiology within astrobiology. So returning to the theme of objectivity in history, objectivity has in the past often been expressed in terms of universality. So the famous German historian wrote that the discipline of history is called upon and is able to lift itself in its own fashion from the investigation and observation of particulars to a universal view of events. But because emergents can go in different directions once they split off, there's no single emergentist template that can be laid over the entire universe. So we can think of two approaches to objectivity. There's the universal approach that in the Ranke quote, but we can also think of objectivity in terms of integrating, that is to say, different accounts that are complementary to each other. And this is very similar to what Gustavo Lau was saying yesterday about his educational experience and learning history in Venezuela and learning history in Peru, and seeing that these different textbooks gave different perspectives on some different events, and sometimes they didn't even have the same events in it. So you need multiple sources of knowledge and integrate them together into a whole. So emergent complexity ultimately might not be objective in the sense of universality and saying a template we can lay over the entire universe, but it may be objective in the sense of integrating many different histories. So I thank you for your attention, and I'm sorry for the technical difficulties, which are still unresolved, and I hope you were able to hear and it made some sense to you. So thank you very much.